Hello ladies and gentlemen, and welcome back to Prospect Charter School's Algebra 2 course. Today we're going over section 2.5, which is 2 linear inequalities in 2 variables. So let's take a look at it. What is a linear inequality? Well, a linear inequality, unlike a nonlinear inequality, is an inequality that deals with lines. So inequalities with lines. But what is an inequality with lines? Now this isn't some person in a play. This isn't some individual telling us whose lines it anyway. No, this is about learning about lines and how they can divide the world into 2 pieces. Because that's what an inequality is when we look in 2 dimensions. It's a way to create a border where one side means one thing, the other side means another. So let's start with something called the boundary. Every inequality has a boundary line. This is the line that separates 2 regions. Just like a border. For an example, we have a boundary line with our northern friends, the Canadians, who are pretty cool. But the line that separates 2 regions in math deals with first graphing that boundary line and then exploring it. So an inequality is a relationship between 2 things. It usually uses inequality signs like greater than, less than, greater than or equal to, less than or equal to. So we're going to be applying that to our functions. Now, I know this will be really confusing at the start, but here's a cool trick. Treat the inequality sign as if it was an equal sign. This is the best trick that I can give to you to help better understand what's going on. When we do these equations, when we graph these lines, well, they're really just lines. You're looking at y equals mx plus b again, except this time you've got Pac-Man running around. So let's look at the notation so we can get into actually graphing these things, because that's going to be the big steak and potatoes or curry and rice portion of this particular lesson. So let's go ahead and go into that. Let's begin with the very simple equation. Y is less than 1/2 x plus 1. Now, if we're being told to graph this guy, we would start out by saying, okay, how do I do that? Well, it's really easy. Step 1, rewrite it. You know how to graph this one, right? There's the slope. There's the y-intercept. With the slope and the y-intercept, they combine to create... No, not Captain Planet. I don't know where you guys get this stuff from, really. No, they combine to create the point and the direction that we need for our line. So if Mr. O'Neill can draw a semi-straight vertical line here. There we go. All right, so we start out at our b value, in this case, positive 1. So I go up to here, positive 1, and I make a dot. That dot tells me where my line is going to start. And then I look at the 1/2. The 1/2 tells me where I'm going. Rise over run. After all, if you've ever tried to run before rising out of your bed, you find you go nowhere fast. So we rise 1 and run 2. We rise 1 and run 2. We drop 1 and retreat 2. We drop 1 and retreat 2. And there we have it, our line. I don't think it was a very good one, but that's okay. My jokes are so bad, none of them are a good line. So then we have to ask ourselves another question. Is the line going to be solid, or is the line going to be dotted? The answer to that question lies with the inequality sign. If you guys have ever been hit by a bar, you know it's pretty darn solid. But if you've never been hit by a bar, if there's no bar to hit you with, then it's like being hit with air, in which case it might just ruffle your feathers, and that's about it. So looking at this, do you see a bar underneath the inequality sign? And the answer to that question is no, we don't. So if we don't have a bar, we're not solid. So how do we show not solid in math? Well, we use a dotted line. And then we have two regions. We are going to have a region that is true and a region that is false. Now, the true region is the area that we're going to highlight, and we can use this beautiful yellow color to highlight or something else. Me, personally, I love teal, so I'm going to use that one. So for the true region, we need to discover which one is it. Is it this beautiful region on top, or is it this beautiful region on the bottom? Well, to figure that out, we use something called a test point. So I'm going to use the test point of 0, 0, because that's usually the easiest thing in the world to work with. So I plug in 0, 0 to my equation. So 0, 0. Here's my test point. Looks kind of like an owl. Yes, you. I'm talking about you. Okay, so Mr. Owl, I'm going to use you as a test point. So we plug in 0 for our x. So we have 1/2 times 0 plus 1. And that has to be greater than the y value. And I plug in the y value of 0. So when I do the arithmetic, 1/2 times nothing is nothing. So nothing plus 1 is still 1. Is 0 less than 1? In which case you should say, well, yeah, of course it is. Duh. Well, in that case, when true, go through. The bottom region is the portion of this equation, or the solution region of this inequality. So that's what we're going to call it. We are going to call it the solution region. And the solution region is the area on the graph that makes true statements. Now note that the dotted line is dotted. That means we don't include the border. So don't include the border. If we had a bar underneath it, then it would be solid, in which case we would include the border. So these are all the pieces of our inequalities. They're actually really easy to work with. If you can do lines, if you can do linear equations, if you can do y equals mx plus b, you can do these. They ain't hard. They're really soft, actually. Kind of like big fluffy pillows made with down feathers. Or maybe really big fluffy pillows made with something else, like cotton. I don't know. Something big and fluffy and soft, like a bunny or a kitten that purrs at you. But of course, with kittens, if you cross the line, you're going to get scratched. So let's take a look at an example where we're not given the simple y equals mx plus b. Let's look at 2x plus 3y is greater than or equal to 6. Now in this case, we are not given the nice beautiful aspect that we had before. We don't have the entire y equals mx plus b thing. We're not even given a point. So how do we do this? Well, we do this using what I like to call the Nixon Method. It is named after one of our presidents, the one who said he was not a crook. It turned out to be false. But that's all right. I'm not going to judge. Mr. Nixon can be happy being who he is wherever he may be. Because I really think that he's kind of buried at the moment. Still, the Nixon Method. Now, the Nixon Method is something really easy to work with. We cover up. We start out by saying, okay, what's my y value? Well, I cover up my x. And I am left with 3y is greater than or equal to 6. Now remember, we can treat these things as if they're equal signs. So if I have 3y is equal to 6, what's the y value? If you said 3, you were wrong. If you said 2, you were right. So at 2, at y equals 2, I have a little dot. There's one of my points. Yay for covering up. Yay for Nixon. So next up, we do the second half of the cover-up method. We cover up the other side. Because, we wanted everything to be bipartisan. So let's make this bipartisan, and we cover up that one, and we end up with 2x is equal to 6. So what's the x value? If you said 4, you're incorrect. If you said 3, once again, good job. So we have a point when x is equal to 3, right here. And can you guess what goes between them? Well, we take a look at our inequality sign. Do we have a bar? Does it go gong when we get hit by it? Yes, it does. So we are going to have a solid line running between them. Now the next question is, which area do we highlight? Do we highlight this as our solution region, or maybe down here as our solution region? And once again, I prefer using a test point. If you use a test point, you can never get it, well, you can get it wrong, but you will very rarely get it wrong. So I'm going to use the test point, and can you guess who? Yep, it's that owl again, 0, 0. Yes, we're talking about you again. We plug in 0 and 0 and see if it makes a true statement. Remember, if true, then through, if false, flee. So let's plug in 0 for x, so we have 2 times 0, plus 3 times, well, we're going to plug in 0 for y, and we're going to see if that's bigger than or equal to 6. So is 0 bigger than or equal to 6? Nope. It's false. So what do? We run away. We pretend like we are in Monty Python's Quest for the Holy Grail, attacking that fort by hitting it with swords, which is kind of really silly if you think about it. Anyway, so we can't go into this bottom region because that would make for false. So for the true area, we have to be on the other side of the border. So here is our new solution region. Hooray for solution regions! And of course, our border is solid, so since it's solid, we include the border. Because let's face it, if the border had a bar, there would be a lot of guys at it. Alright, so that's about it for linear inequalities in multiple variables. It's all about setting things up, looking for your solution region. Remember, you can always treat the inequality sign as if it's an equal sign, and then worry about the other stuff later. If all else fails, turn it back into y equals mx plus b format. That's okay. I will not judge you. I'll probably just frown at you and say you can do better, because you can. You guys are smart. If you guys weren't smart, I wouldn't be teaching you. So it's okay. It's okay if you have to revert to another format. It's fine. I don't mind at all. So here we go. Your favorite part of the evening. The part where you pull out your books and start actually doing something. The part called homework. Hello, Mr. Work. Say hi, Mr. Work. Alright, so our homework for this evening is going to be section 2.5, numbers or hashtags, 1 through 13, odd, and then 15 looks really good, 17 looks really good, 19 looks really good. I know I should have just said 1 through 19 odd, right? Oh well. 23 looks really good. 25 looks pretty fun. And of course, because why not do stuff for school, 34 and 35. Alright, that should be it. That should be plenty of work for you guys to do. Go ahead and get started. And remember, good luck and have fun.